Welcome to On Chemistry. In this video, we are going to see Cram's rule, basics and mechanism involved in the Cram's rule, and more importantly, we are going to solve 20 problems from various examinations. Stay tuned. What is inside this video? First, we will see what is Cram's rule, then basics including mechanism, then trick to identify the product, then variation in the Cram's rule, that is anti-Cram's rule or chelation model, then common mistake involved in the prediction of the product. Finally, we will end up with the example, that is fully solved examples from various examination. It will be very useful for you to crack any examination. Let us see what is Cram's rule, what are the basics behind it, mechanism and trick behind that, and trick to identify the product. First, let us understand why we are using the Cram's rule. Suppose you have the ketone, you are attacking the carbonyl with nucleophile. It is a nucleophilic addition reaction. The attack can be from above and below. Clearly, you end up with enantiomer, that is 50% or 50% yes. There is no major or minor. But if you look at the other situation, that is Q situation, suppose you have one chiral center at alpha position, the whole scenario will change. You won't get 50-50. Here you have major and minor product. This is created because of steric effect. The prediction come from Crams. It will help you to understand the final product. So Cram's rule predict the diastereoselectivity during the nucleophilic addition of carbonyl. Let us see the ideal condition for Cram's rule. In Cram's rule, you have ketone, alpha chiral center. You have attacking nucleophile. Nucleophile can attack above or below. That's what you have equal possibility. But steric groups in the alpha position decide the final product. The attack happen away from the bigger groups. That is what the Cram's rule. Major product is less hindered product. Basically, you are converting prochiral into chiral center with high selectivity. So you can say it is asymmetric synthesis or diastereoselective synthesis. Here, the main factor decide the final product is large group in the alpha position and it is relation with carbonyl. So the model we will see, alpha position you have the chiral center. We will draw in the Newman projection in the eclipsed pathway, carbonyl and large group trans to each other. If you look at it, nucleophile attack from the small side because large atom cannot accommodate the incoming group because it is coming with the charge and electron. So attack happen on the smaller side. That's what the diastereoselectivity comes. Small side attack create the selectivity. Then the important thing, you should know the trick. Every time you cannot draw the Newman projection, find the attack, predict the final product is hard. So simple trick is find the relation between large group and carbonyl. Here you have two set of configuration. In P you have large group and carbonyl syn to each other. In Q, phenyl and large group anti to each other. So that is the important thing. So you should find the relation between phenyl and carbonyl. Then you can decide where the attack will happen. If the relation is syn, the attack will happen on medium side. If the relation is anti, attack will happen on small side. This can be confusing. That's what I given acronym like LACE, large group, anti, small side attack. So you can use the acronym, avoid the confusion, predict the final product. This will help you to find the product quickly without drawing the structure, without writing the mechanism. So memorize this table. Then the important variation, Cram chelation model. What is that? Suppose you have Z group, that is chelating group present in the system in basically ligand in the alpha carbon which can coordinate with the metal. So it will inverse the selectivity as well as improve the kinetics of the product. Why? because carbonyl can be activated by the Lewis acid and metals. So activation happened. Anti-Cram's rule followed. In Anti-Cram's rule, you have the table exactly opposite to Cram's rule. Then we will see the condition for Anti-Cram's rule. The alpha position, you have either oxygen, phosphorus, nitrogen or sulfur. All are lone pair containing atoms. Basically, it can coordinate with metal. Chelating agents are magnesium, zinc, copper, titanium, cerium, magnesium, manganese, lithium. So you should know the ligand, you should know the metal and chelation possibility. Here non-chelating groups are halogen, chlorine, bromine, iodine and some of the metals also cannot hold the chelation because of their smaller size. Example sodium and potassium. So you should know the exceptions. Here Z group is the deciding group, not the large group. Z group may be a bigger group or medium sized group, but it has controlling character. If Z group and CO syn to each other mean small side attack, anti mean medium side attack. So it is completely opposite to Graham's rule. Syn means small side, anti mean medium side. In anti-Graham's rule, let us see one confusing factor. The Z group is a coordinating group, but it need not to be a large group. We will analyze that by example. In example 1, large group is PHO, that is also a Z group. It is the coordinating group. Here we don't have any confusion, but if you go example 2, the large group is ethyl group, medium group is OH, that is the Z group. But in anti-Cram's rule, Z is important, not the large or medium. So, the fact you should learn here is Z group need not to be the large group, but it has higher priority in the anti-Cram's rule. Here, to avoid the confusion, better we will see Cram's rule versus anti-Cram's rule. Both are same, but in the sense of coordination, anti-Cram's rule differs. Cram's rule dictated by the large group, anti-Cram's rule dictated by the Z group. Cram's rule, large group and CO syn mean medium side attack, anti means small side attack. Here large group is important and the anti-Cram's rule, Z group and CO syn to each other mean small side attack, anti mean medium side attack. Here Z group is important. Z is group with lone pair. It can coordinate the metal. All others are same. Only inversion of the selectivity. Next, very important thing, position of alpha chiral center. Here the selectivity is created by alpha chiral center. If the chiral center is away from the carbonyl, there is no selectivity, there is no Graham's rule. That's what's shown here. First example, alpha carbon is positioned nicely. You have diastereoselective synthesis with very good yield. On the contrary, if the alpha center is away from the carbonyl, here 4 carbon away, there is no selectivity, no steric effect, so no chiral carbon, so no Graham's rule. Mixture of products obtained, mostly racemic. By now, you might realize finding the anti-position is critical. So you should know step by step. First step is remove the hydrogen if there is any. Then write the carbon skeleton. Then find the relation between big and small group. But most of the time, remove the wedge and dotted structure. You have simple linear line structure which will tell whether it is syn or not. Here methyl is on solid line. Hydrogen and ethyl all are removed. Here only methyl is there. That is in syn relationship. So definitely ethyl in anti relationship. So finding the anti position is critical. You can use the step for identification. Here I would strongly recommend that careful with anti because it will be deceiving. It can be simple carbonyl with linear structure or it can be carbonyl above or below or it is a just rotated compound. Either way the structure is same or all are skeletal structure or Saga's projection, or without any clarity, simple CHO is given mean CHO written as combined, no clarity. So careful with the anti, you have to master the stereochemistry to master the anti position. Here, the last and simple note on basics. To avoid the confusion, you should always draw with all the atoms. Here, starting metal given without hydrogen. If you redraw with hydrogen, you have clear note that whether the compound is syn or anti, stereoselectivity is possible or not. So you should master the stereochemistry to master the Crams rule. Then you might come across the fact that model. Always you listen model. There are three known model: Crams model, Felkin-Ann model, Comfort model. Crams model we seen, Felkin-Ann model also will give same result but with different conformation like staggered position. But in Cram it is eclipsed position. Comfort only for halogen or O-methyl. All will give same result, just a different clarification and better understanding. You need not to worry about this model. Just go with the table and find the final product. Before getting into the problem, we should know how to find the product step by step. First step would be find whether the Crams rule or anti-Crams rule applied. That is the very important thing. If you confuse that, you won't get the product right. Then mark large, medium and small group. In case of antigrams, mark Z group. Then find the CHO relationship with large group or Z group. Then if you know the relation, use the table to find the product. If sin grams rule, medium side attack comes. Anti-grams rule, small side attack comes. If it is anti-grams rule, small side attack. Anti-grams rule, medium side attack. Then write the product with stereochemistry. Here important thing is don't forget the exception in anti-grams rule. Sodium and potassium don't chelate as well as collagen don't chelate. Then we are going to the very important session, 20 fully solved examples. Why we are solving so many examples? Because problems are best way to learn. Problems will give better perspective, confidence and error-free understanding of concept. Let us see the first example. Here you have aldehyde. Alpha position you have cyclohexane on the plane, methyl above the plane, hydrogen below the plane. You are heating it up. Grignard reagent you are using CH3MgX. You should find what will be the final product. Here there is no coordinating group, so obviously Crams rule, not the anti-Crams rule. Let us mark the group small, medium and large. Small group obviously the hydrogen, large group obviously cyclohexane, medium group is CH3. So let us analyze the relation between large group and carbonyl. Carbonyl and large group syn to each other. Nucleophile is CH3. Where it will attack? According to the table, large group and CO syn to each other mean medium side attack. Here medium group is methyl. Methyl above the plane. So attacking methyl also above the plane. So methyl attacks above the plane. OH go below the plane. Hydrogen already on the plane. Here you have selective major product. The concept you have to learn here is mastering the stereochemistry help you to write final product better. Then the next example, here you have ketone, one side methyl group, another side you have chiral carbon, hydrogen above the plane, methyl below the plane, tertiary butyl group is on other side. So basically a chiral carbon, heating and Grignard reagent you are using, that is ethyl magnesium halide. You should find what will be the final product. Here you don't have any coordinating group. Ketone is there. Alpha chiral carbon is there. Attacking species is nucleophile. So Gram's rule. According to Gram's rule, we should find first relation between large, medium and small. According to the Gram's rule, first you should label the atom. Large group is tertiary butyl group. Small group is hydrogen. Medium group is methyl. Our aim is to find the relation between carbonyl and large group. Here both are syn to each other. So according to the Huckel rule, large group and CO syn, the attacking species will be on medium side. Here medium group is methyl group which is below the plane. So attacking group also below the plane. Attacking species is ethyl. It attacks below the plane. So OH above the plane. Another methyl is on the plane. So here is on final product. The concept you have to learn here is whenever you see tertiary butyl, most of the time it will be the large group. Then the next example. Here Sahar's projection is given. Ketone is there. One side methyl group. Another side you have secondary carbon with methyl and phenyl. Methyl towards you, hydrogen behind you. You are heating it up. Lithium aluminum hydride you are using. You should find what will be the final product. Here the new thing is Saha's projection, but let us stick with basics. Here carbonyl you have and alpha position you have chiral carbon because all three different attachment and attacking species is nucleophile. There is no coordinating group. So obviously Gram's rule you should apply. So the first step will be finding large, medium and small group. Large group is obviously a phenyl, medium group is methyl, small group is hydrogen. Here the relation between large group and carbonyl, clearly the anti-relationship. pH below the plane, carbonyl above, both are 180 degree to each other. So anti-relationship. So large group and CO in anti mean attacking nucleophile, attack on small side. Here small side is hydrogen. So attacking species also attack from hydrogen side. Hydrogen away from you. So attacking species also attack behind the plane. OH come above the plane. You have the final product. The concept you have to learn here is even in Saga's projection, you should master the Gram's rule to identify the final product in Gram's rule. Then the next example, here you have carbonyl, that is aldehyde. The attachment is chiral carbon which is in alpha position. You have methyl, hydrogen and phenyl. Methyl above the plane, hydrogen below the plane. You are heating it up. Grignard reagent you are using, that is phenyl magnesium halide. You should find what will be the final product. Here you don't have any coordinating group. Carbonyl you have alpha position, you have chiral carbon. Attacking species is nucleophile. So Gram's rule. So the first step will be identifying large, medium and small. Phenyl is the large group. Methyl is the medium group. Sulfur is the smaller group. We should find relationship between large and carbonyl. Large and carbonyl opposite to each other. Both are in 180 degree. So large group and carbonyl is anti. Attacking species will be on small side. Here smaller group is hydrogen which is below the plane. So attack also will happen below the plane. So hydrogen below. pH also attack from below. So OH come above the plane. So clearly stereochemistry is defined. You have selectivity and you have the final product. The concept you have to learn here is identifying the large group and its relation between CO is important to find the final product in Gram's rule. Then the next example. Here you have aldehyde. Carbonyl group is there. Alpha position you have chiral carbon which has hydrogen above the plane, methyl below the plane, ethyl is on the plane. you are heating it up. Grignard reagent you are using, that is phenyl magnesium halide. You should find what will be the final product. Here you have carbonyl group. Alpha position you have chiral carbon. Attacking species is phenyl. So obviously the Crams rule. Since there is no coordinating species, obviously the Crams rule. So the first step will be labeling large, medium and small group. Large group is ethyl group. Medium group is methyl group. Small group is hydrogen. Here we should find relationship between large group and carbonate. If you look at it, both are syn to each other. So the large group and carbonate syn to each other mean attack will be on medium side. Here medium group is below the plane, so attack will be also happen below the plane. So phenyl attack from below, OH come above the plane. You have the final product. The concept you have to learn here is the table is important to easily identify the final product. Then the next example. Here you have ketone. One side phenyl group, another side phenoxide and methyl. Methyl above the plane. Butyl lithium you are using. You should find what will be the final product. Here you have alpha chiral carbon. Redraw the molecule with hydrogen. Hydrogen below the plane, methyl below the plane, phenoxide in the alpha carbon. The oxygen attachment, it can act as a Z group because of its lone pair. Butyl lithium you are using. Lithium can hold the coordination. So possibility of anti-Cram's rule. So careful with the choices. Here large group and Z group both are same. So the first step will be identifying the large, medium and small. Z group is obvious, that is phenoxide. That is also the large group. Small group is hydrogen. Medium group is methyl group. Here you should find the relation between CO and Z groups into each other. Since it is the anti-Cram's rule, it is opposite to Cram's rule. The Z group and CO syn to each other mean small side attack. Here small is hydrogen, so butyl lithium is the nucleophile here. It attacks from the back side. You have final product which OH above the plane, which has OH above the plane. So the final product you have anti-Cram product. The concept you have to learn here is in anti-Cram's rule, you should write the product exactly opposite to Cram's rule. Then the next example, here you have aldehyde, one side with hydrogen, another side long chain alkyl group. It has 6 carbon. The sixth carbon is chiral carbon, which has methyl above the plane, hydrogen below the plane. You are heating it up with lithium aluminum hydride. You should find what will be the final product. Here there is no Cram's rule. Why? Because chiral center is away from the carbonyl, so steric effect is not effective. So there is no steric crowding. So Cram's rule is not applied. So what will happen? If Cram's rule not applied means final product is reduced product, carbonyl to alcohol, but without selectivity. So you have the mixture of product, probably the racemic product. So the concept you have to learn here is the chiral center should be on alpha carbon. If it is away from the alpha carbon, there is no steric effect. So the Cram's rule is not applicable. Then the next example. Here you have aldehyde. In carbonyl, one side you have hydrogen, another side you have chiral carbon. Chiral carbon contain methyl above the plane, hydrogen below the plane, phenyl is on the plane. You are heating it up. You are using the Grignard reagent, which is phenyl magnesium bromide. You should find what will be the final product. Here you have chiral carbon at alpha position. You have carbonyl. there is no coordinating group. So obviously the Crams rule. So let us mark large, small and medium group. Here small group is hydrogen, methyl group is medium group. So large group is phenyl group. The relationship between large group and carbonyl is anti. So according to the table, large group and carbonyl is anti means small side attack. Here small side is hydrogen. So attack also from hydrogen side. Hydrogen below the plane. So phenyl also below the plane. You have the final product which is phenyl below, OH above the plane. The concept you have to learn here is you should not worry about the molecule, stick with fundamental and identify the final product. Then the next example, here you have ketone, one side you have methyl group, another side you have ethyl and tertiary butyl. Ethyl is on above the plane. You are using sodium borohydrate in methanol. You should find what will be the final product. Here the starting material is twisted because it is without hydrogen and its stereochemistry. So we redraw the molecule with hydrogen which is below the plane, ethyl above the plane, tertiary butyl on the line. Here you have carbonyl, alpha chiral carbon. Attacking species is nucleophile. So according to the Gram's rule, you should find large, medium and small. Large group, obviously the tertiary butyl group. Hydrogen is small, ethyl is medium. We should find relationship between large group and carbonyl. The relationship is syn. Large group and carbonyl is syn mean. According to the Gram's rule, you have medium side attack. Here medium is ethyl group which is above the plane. So attacking species is hydrogen. Attack from above the plane. So hydrogen attack from above. OH come below. So you have the final product. The concept you have to learn here is always write alpha carbon with full stereochemistry. Then the next example, here you have ketone. One side you have alkene, another side you have phenyl and methyl attached with single carbon. You are using lithium aluminum hydride at low temperature. You should find what will be the final product. Here starting material is carbonate. It has alpha chiral carbon and attacking species is nucleophile. Since there is no coordinating species, Cram's rule will be applied. Here another alpha side you have alkene. So it is alpha beta unsaturated ketone. So don't confuse with 1,4 addition. Here our focus is Cram's rule. Here it will go 1,2 addition. So obviously the Cram's rule. First step will be identifying medium, small and large group. Here large group is phenyl, medium is methyl, small group is hydrogen. Next you should find relationship between large group and carbonyl. Large group and carbonyl syn to each other. Large group and carbonyl syn to each other mean attack will be on medium side. Medium group is here methyl, so attack will happen on methyl. Hydrogen is the nucleophile. It attacks from methyl side which is above the plate. So OH below the plane. Here you have the final product. The concept you have to learn here is sometimes starting material is twisted. You stick with fundamental to identify the final product. Then the next example. Here you have ketone. One side you have phenyl group. Another side you have linear chain. Alpha position you have chiral carbon which is OH above the plane, hydrogen below the plane. You are using zinc borohydride. You should find what will be the final product. Here you have ketone. Alpha position you have chiral group. Chiral group contain OH which is coordinating species. You are using the zinc. So the chances of anti-Cram's rule. Here you have ketone, alpha position you have OH. It is a coordinating group. You are using zinc borohydride. Attacking species is nucleophile. So anti-Cram's rule. Here OH is coordinating species. Then you should mark large, medium and small. Large group is ethyl group. OH is medium group. Hydrogen is small group. In anti-Cram's rule, relation between OH and CO is important. OH and CO is anti to each other. So according to the anti-Cram's rule, Z and CO anti to each other mean medium side attack. Here medium group is OH which is above the plane. So attack will be on above the plane. So hydrogen attack from above. OH go below. You have the final product. The concept you have to learn here is OH can be a medium group, need not to be a large group. Even though OH is a medium group, it has high priority because of coordinating ability. Then the next example, here you have ketone. The compound is given in Sagas projection. One side you have methyl group, another side you have chiral carbon with 3 attachment, hydrogen, methyl and phenyl. You are using ethyl magnesium bromide. You should find what will be the final product. Here the compound in Sagas projection. Don't confuse. We stick with fundamentals. Here you have carbonyl. Alpha position you have chiral carbon. Attacking species is nucleophile. There is no coordinating group, so chances of Cram's rule. We should identify large, medium and small. Large group is phenyl, medium group is methyl, small group is hydrogen. The relationship between carbonyl and large group is important. Here it is syn to each other. So according to the Cram's rule, large group and CO syn to each other mean medium side attack. Here medium group is methyl group which is behind the plane. Same angle you have attacking of nucleophile. So C2H5 attack from below. OH come above. So you have the final product. The concept you have to learn here is whatever the conformation or the configuration, you should stick with fundamentals and find the product. Then the next example, here you have ketone. One side you have methyl group, another side you have long chain. Alpha position you have chiral carbon that has hydrogen above the plane, methyl below the plane. You are using phenyl magnesium bromide. You should find what will be the final product. Here you have ketone, alpha chiral carbon. Attacking species is nucleophile. There is no coordinating group, so chances of Cram's rule. So you should find large, medium and small. Large group is obviously the propyl group. Medium group is methyl. Small group is hydrogen. The relationship between large group and the carbonyl is syn to each other. So according to the Cram's rule, large group and carbonyl syn to each other mean attack will be on medium side. Here medium group is methyl. So the attack will happen on methyl side. It is below the plane. So attack will be happen below the plane. Phenyl attack from below. OH come above. So you have the final product. The concept you have to learn here is always crucial to find the relationship between carbonyl and large group in alpha chiral carbon. Then the next example. Here you have ketone, one side with phenyl group, another side you have chiral carbon which contain OH above the plane, hydrogen below the plane, ethyl is on the plane. You are using the two different reagents, sodium borohydride and sodium borohydride with cerium chloride. You should find what the difference the reagent can make. Here the question is very much interesting because of its products. Here you have carbonyl, alpha position you have chiral group with OH. OH is the coordinating group, so the chances of anti-Cram's rule. But the trick is sodium cannot coordinate with oxygen. It follow Gram's rule. On the contrary, cerium can chelate with OH, form the anti-Gram's rule. So two different reagent, two different mechanism. First let us see Gram's rule. Here Gram's pathway decided by the large group. You should know the fact that large group and Z group both are different. So careful. Gram's rule large group syn to carbonyl. Large group syn to carbonyl mean medium side attack. Here medium is OH group. It is above the plane. So hydrogen also attack above the plane. So the final product hydrogen above the plane, OH below the plane. On the contrary, cerium chloride anti-Gram's rule follows where Z group has high priority. Here Z group is OH which is anti to CO, so attack will happen on OH side. So according to the Gram's rule, Z group and CO anti mean attack will happen on medium side. Here medium is OH group, so attack will happen on OH side. Since OH above the plane, hydrogen also attack above the plane. You have the final product. The concept you have to learn here is large group and Z group need not to be the same. So careful with identification and application of Gram's rule and anti-Gram's rule. Then the next example. Here you have carbonyl. It is the ketone. One side you have phenyl. Another side you have chiral carbon. Amine and ethyl and hydrogen are there. Hydrogen below the plane, ethyl above the plane, amine is on the plane. You are heating it up. Methyl mercury you are using. You should find what will be the final product. Here you have alpha chiral carbon, ketone, and you have coordinating amine. So chances of anti-Gram's rule. Let us mark large, medium and small. Large group is ethyl, medium group is amine, small group is hydrogen. Since it is an anti-Gram's rule, relationship between amine and carbonyl is important. It is syn to each other. According to anti-Gram's rule, Z group and CO syn to each other mean attack will happen on small side. Here small group is hydrogen, so attack will be happen on hydrogen side. Hydrogen below the plane, so methyl also attack below the plane. Methyl attacks, methyl below, OH above. You have the final product. The concept you have to learn here is large group and Z group can be different and it can create the confusion. Careful with anti-Cram's rule. Then the next example. Here you have carbonyl. Alpha position you have chiral carbon which is O-methyl. Hydrogen below the plane. Methyl above the plane. Phenyl is on other side. You are using sodium borohydride. You should find what will be the final product. Here you have carbonyl, alpha chiral carbon, but twist is it has O-methyl group. The metal is sodium. It cannot coordinate with metal, so not the anti-Gram's rule. So careful with metals. Sodium cannot coordinate, so Gram's rule followed. Let us mark large, small and medium. Here large group is O-methyl, medium is methyl, small group is hydrogen. The relationship between carbonyl and large group is important. Here it is syn to each other. So according to Gram's rule, large group and CO syn to each other mean attack will happen on medium side. Here medium group is methyl which is above the plane. So attack will happen above the plane. So hydrogen attacks from above, OH go below. So you have the final product. The concept you have to learn here is sodium cannot coordinating with ligand. It will not follow Anti-Cram's rule. Then the next example. Here you have ketone. One side you have alkene. Another side you have chiral carbon. Hydrogen above the plane. Methyl below the plane. Phosphine oxide on the plane. You are using sodium borohydride and cerium chloride. You should find what will be the final product. Here starting material is ketone. You have alpha chiral carbon, but you have phosphine which is coordinating group and you are using cerium. So chances of anti-Cram's rule. So first step will be assigning large, medium, small and Z group. Here large group and Z group same phosphine, medium group is methyl, small group is hydrogen. Finding the relationship between Carbonyl and Z group is important. Here it is syn to each other. According to Anti-Cram's rule, Z group and CO syn to each other mean attack will happen on small side. Here small group is hydrogen. It is above the plane. Attacking species also a hydrogen. So it will attack above the plane because small group is above the plane. H attack from above, OH go below, you have the final product. The concept you have to learn here is phosphine also coordinate with metal. It follows Anti-Cram's rule. Then the next example. Here you have aldehyde. Alpha position you have chiral carbon, phenyl, methyl and hydrogen. Hydrogen below the plane, methyl above the plane. Here you have organometallic compound, allyl with silane, titanium tetrachloride you are using. You should find what will be the final product. By looking at the starting material, don't get confused. Stick with fundamentals and find the product. Here there is no coordinating group, so obviously the Crams rule. The attacking species is silyl carbon, which is an organometallic compound. Donate the nucleophile, which is allyl. So alpha chiral carbon, nucleophile. So the chances of Crams rule. Let us assign large, medium and small. Large group is phenyl, medium group is methyl, small group is hydrogen. Large group and carbonyl relation is important. Both are anti to each other. So according to the Crams rule, large group and CO anti mean attack will be happen on small side. Here hydrogen below the plane. So attack will be happen below the plane. So allyl group attack from below. OH come above. You have the final product. The concept you have to learn here is silane also organic metallic compound. It donates simple nucleophile like Grignard reagents. Here you have aldehyde. Alpha position you have methyl group and O methyl group. Methyl above the plane, O methyl on the plane. You are using zinc borohydride. You should find what will be the final product. Here you have carbonyl. Alpha position is with chiral carbon. You should redraw that with hydrogen. So hydrogen below the plane, methyl above the plane. Zinc borohydride you are using. Since O-methyl can coordinate with zinc ion, chances of Anti-Cram's rule. Let us assign large, medium and small. Here large group is O-methyl group. It is also a Z group. Medium is methyl group. Hydrogen is small group. In Anti-Cram's rule, relationship between Z group and carbonyl is important, which is syn to each other. So according to Anti-Cram's rule, Z group and CO syn to each other mean small side attack. Here small side is hydrogen, which is below the plane. Attacking species also hydrogen, so it will attack below the plane. OH come above the plane. So you have the final product with OH above, hydrogen below. The concept you have to learn here is zinc also coordinate with oxygen and promote the anti-Cram's rule. Then the final example. Here you have carbonyl. It is a ketone. One side methyl group. Another side you have ethyl, methyl and hydrogen. Ethyl above the plane, hydrogen below the plane. You are heating it up and using lithium aluminum hydride. You should find what will be the final product. Here you have carbonyl, alpha chiral carbon. So the chances of Cram's rule. Let us assign large, medium and small. Here large group is ethyl, medium group is methyl, hydrogen is small. The relationship between CO and large group is anti. So attack will happen on small side. Here hydrogen is small one which is below the plane. So attack will happen below the plane. So hydrogen attack below, OH come above. You have the final product. The concept you have to learn here is assigning large, medium and small group is important. Always be careful. Find the product. Let us summarize what we learned. First, you should know Cram's rule and Anti-Cram's rule. Anti-Cram's rule, you have coordinating group as well as metal. In Cram's rule, relationship between large group and CO is important. Anti-Cram's rule, relationship between Z and CO is important. Z group is coordinating group, mostly with oxygen, nitrogen and sulfur, rarely with phosphine. The chelating agents are magnesium, zinc, copper, titanium, cerium, methyl, magnesium, manganese and lithium. Here non-chelating groups are fluorine, chlorine, bromine, iodine. Non-chelating metal ions are sodium and potassium. In Graham's rule, large group and CO, sin mean medium side attack. Anti-Graham's rule, small side attack. Large group and CO, anti mean in Graham's rule, small side attack. Anti-Graham's rule, medium side attack. So you should master both Graham's rule as well as anti-Graham's rule.